scholars and what roads and solutions. I don't know, technically about yesterday and I didn't respond. I assume your mom.
No. Like the first time. Yes. Hi everyone, let's get started for today. So today we'll be talking about manipulating the DOM with the standards API, how we do events in JavaScript, and then we'll go into details about D3 selections, data binding, scales, access, and the key functions. So these are kind of like the most important aspects of D3 that we'll be covering in detail today so that we understand everything of what that happens under the hood. Before we start, announcements. Carolina is leaving town tonight, so she will not be holding office hours, but she will be helping out on Slack. There is going to be a homework lab tonight in the same room as usual, 6 p.m. And we'll walk you through the homework 3 there. And homework 3 is, there's nothing like super special about it compared to what you did in homework 2. It's a couple of additional concepts, and you will also be using the DOM manipulation what we are covering for the very first example. Any questions about homeworks or projects or anything like that? Great. I'll be talking a little bit more about the projects in one of the next lectures. And then give you a couple of pointers how to start a project, how to find a group, and where to find data sources and so on. Okay, so we're talking about DOM manipulation today. So what is like we talked about what the DOM is. The DOM is essentially the representation of all the elements as they are rendered by the browser. And we distinguish between HTML, which is kind of like can be equivalent to the DOM, but if we dynamically manipulate the DOM with JavaScript, there is a difference between your sources and what you see in the DOM. And the DOM is both this tree of elements and the DOM API. And so we'll be looking at both today. One of the most important things, like if you want to access the DOM from JavaScript, what you do is you use the document object. The document object is a global variable that you have accessible in the browser, and you can also look at the MDN reference on the document object, which essentially gives you details on what it can do and what it can't do. It's a pretty long, pretty big object with many properties about the browser, and so on. So let's take a look at this piece of code here. So the first thing we're doing here is we're logging the document. This is a variable that contains the actual document here. So you can see this is essentially by running console.log document, I am logging everything that we would otherwise see here in the element browser, right? So this is exactly the same thing. Now, if I want to select a single element, there is a function on the document that is defined with document.getElementById. And then here I'm using main div, which I have used here. Like this is the div that I've given the ID main div. And so now I'm simply saying document.getElementById main div. Notice this is different from what we did with the select in D3. In D3 we added the hashtag here, right? But in the DOM API you have a getElement by class, getElementById, and getElementByType, and so on. Please don't quote me on the exact syntax, but there's different functions for all of these different types of accessors. Whereas D3 and jQuery the same, to make this and CSS, they use these like hashtag or dot syntax instead. So we can log we can log any of these elements. So you can see this is our main div element here. So we can take any of the elements that we retrieve from the DOM and then log it. And we can also modify it. So here I'm calling document.create element. I'm creating a paragraph element. This is my new paragraph element. Then I'm attaching a child. Like this is only defined on one of those DOM elements. I call new paragraph.append child. And then I call document.create text node. And then I put in here some text that we dynamically created in JavaScript. And then I append this new paragraph to the div. So I've done a very manual operation. Like first I have retrieved an existing div element. Then here, independent of that, I have created a new element that is not at this point assigned anywhere to the DOM. Then I have added text, create a text node to that paragraph element. And then I have appended that to the main div. And then we see this is kind of like the result of this. This is the new text node. This is the text that was originally specified in HTML. Here is the new paragraph that we created here in this create element. And then here's the text that we created within this, like in this function here, create text node, and that we appended to the paragraph. And that is then appended to the main div, and therefore is also rendered here in the output. So this is like pretty long. If you compare how quick and easy that was in D3, this is like the much more verbose way of doing it, but this is the standard way of doing it, right? You can do that without including any libraries, and D3 does exactly that behind the scenes. Yeah, so just to recap, we had the get element by ID, we had create element, which created a new element, the create text node, which created the new text element within the nested element, and then we had used append child to attach a node to a parent. Okay, so in this example, we can also like create a little bit more complicated program that dynamically creates a website. So what we have here is simply like this. This is the output. We have some text that was specified in HTML, and this here was all specified by JavaScript. So you can see that the HTML here only has this text in HTML. And so what do we do here is we have a function, a helper function that creates a div element and text within that div element. And so you pass in the text element, you say document, create element, a div element, then create a text node, pass in the text variable, then append the text node to the div and return the div. So this is just a helper function. Now I'm retrieving the main div and store it in this global variable here. And now I'm iterating like over a loop from 0 to 10. And I append child with the text of I multiplied by I. And so this is what we get here. Okay, so we get 1, 4, 9, 16, 25, and so on. And that is like, and here, all we do, like here we retrieve the div element, and then down here we, here we actually retrieve the div element from the function, and here we append it, and then down here we do another one outside of the loop, the X down here. Okay, so this is how you add elements in the DOM. We can also control the attributes of elements, for example, by styling or positioning them. So what we're doing here is we're creating this wonderful rainbow of numbers. And so what do we need to do this? We have the same div with text again up here. Then we style by setting the position and the color. So we create a node and then we set the attribute, position it absolutely. Left is like we pass in here a text at X and the Y position, and then we adjust this here. I'm using a couple of modulo operations because I only want this to be shown in the first 50 pixels here, and that is kind of repeating in Y direction. And then I'm defining the color as a function of the X value. I'm using the HSL color model, which is hue, saturation, lighting. So the first parameter of the HSL color model is our hue. And then I'm using here X modulo 255. We have 255 colors by default. And that means we have this like cyclic colors. So you can see that we have the same cycle across the rainbow here happening over and over again, like at 0, at 90, at 170, and so on. And then I'm simply again running a loop where I append children, like these text element children that are absolutely positioned to like within 10 unit increments at these like various positions. 3 multiplied by I, 3 multiplied by I for x and y. Remember that we had the modulo for the y position, that's why it extends further to the x position than to the y position. So this is all like pretty obvious. The interesting part here is the set attribute, obviously. This is what you, like the new function from the DOM that we haven't talked about. We can then do something crazy, like 90s style JavaScript. Have like evolving and like running, blinking numbers here across our screen. So how do we do that? It's like it uses, like most of the code is the same. The interesting new piece is, should we have to have kind of some kind of timing mechanism? And so what we do for this timing mechanism is 2 things. We let the node update itself. And so this is like the nice thing about JavaScript, that we can assign functions at runtime to objects, just as we can create, like add new variables to an object at runtime. We can add a new function associated with a node at runtime. And so here we are defining a new update function that is then associated with the node. So node.update is a function, and here it happens like the update is what is the delta. The node, the function bakes in the v, increases it by the amount, and then does the styling here. This is again pretty similar. The only difference here is that I also add a modulo 800 to simply like have this wrap around. So like the modulo 800, make sure that this starts here on the left again. This is exactly 800 pixels wide here. And so this is the update function, and then like this, the code actually starts executing here. We initialize a list of nodes, and with these different I values, with these different positions. Then we append these children that we retrieve from the number text to the main div. We store that in an array. And then what happens is we call this tick forever function. This tick forever function, I'll come back to that calls the tick function. And the tick function itself iterates over the list of nodes and updates it by 1. So this is for every node in nodes, increased by 1 essentially. And so now the interesting part is the tick forever. The tick forever calls the tick function and then recursively calls or passes itself on as a callback to the request animation frame. And request animation frame is the important thing here, because this is like if I just were to do, for example, a while loop as I do down here, while true, just tick and continue updating, we would essentially like bake our CPU and would basically, we wouldn't see much. It would actually crash your browser window because it would simply loop as fast as it could. What a request animation frame does, it provides a callback, and this is only called every time the browser re-renders. This is like maybe 30 frames per second. And so every time the browser re-renders, this callback that we pass into request animation frame is called. So it calls tick forever every time the browser re-renders. That calls tick, and that's what does the update. And so then it can create like a animated web page like this. And so if you do this, it will actually crash your browser. So if you don't believe me, try it. But okay, so this is kind of like the most important parts that I wanted to talk about. The DOM API. There's of course much more to it, but these things show you the most important aspects of it. So you should be fine. you only need to add a couple of bar charts into the SVG. And of course, as you know, SVG is just just like regular HTML part of the DOM, so we can apply everything that we did here to elements of the SVG directly. Okay. So then next, we have kind of used, like you will be using in the third homework, you will be using some events. There's a couple of different ways that you can specify events in JavaScript. There's also a couple of different ways that you can do them in D3. I'll be talking briefly about this later. But the JavaScript ones are pretty simple. So you have essentially two options. You can explicitly define what happens on a certain event when you define the HTML. So here, what I have here is like two buttons and a text. And when I pick one button, one function is called. It says, yes, it's me, button 1. If I click the other button, it says, you chose me, button 2. It doesn't have to be a button though. I can pick any div or I can pick any element in the DOM. I can interact with any element in the DOM. So the buttons, they are meaningful in terms of semantics because people know that they click there, but a button does exactly the same thing as any other DOM element. I can listen to exactly the same events. So there is no difference. And so like all of these call a function, and there's different ways in which we specify how to call that. So here we have a direct reference to a function to message me in HTML. So this is essentially, here what is important is the signature that we have here. And so this is like, if this button here is then clicked, then this function is called and the alert box in JavaScript is triggered. The other way of doing this is by specifying or by identifying a button in JavaScript and listening to that event. So here I'm using the DOM API to retrieve an element by ID, which is my button, which is exactly what I had up here. And then I say on click, execute that function. And this is how I define this callback now. I personally prefer that approach, even though it's a little bit longer. I think that is kind of a little bit more sensible because you kind of keep your functions to JavaScript and don't assume function names within your HTML. So I think that is the cleaner version of doing things, but both of them actually work. This is more robust, for example, to refactoring. If you change your method signature, your IDE can catch that easily. This here is not as easily caught by your IDE, so you might get some, you might lose some events. And here I'm using the onClick, like the same method as I did at the top on the div, just to show that this is doesn't depend on a button. And so here this is like the div message that is being called. And again, I can click here and then I get the alert box to show up. So very, very simple. What do we have here? Yeah, so here is another example for an event. And so there's a lot of different types of events, right? There's an on-click, there's on-hover, there's on-load, there's on-change, and so on. And so there's a long list of these useful events that you can retrieve from the MDN web docs. So you see there's on animation cancel, on aux click, on blur, on error, on focus, on can play, and so on. So there's like a long, long list of events that you can listen to. Of course, it should make sense, right? And not all browsers will support all equally well. So I would assume that on volume change is something that is probably rather newish. So here we are listening to an event. Like what we have is we have a drop-down box with 3 fruit, pear, apple, and plum. And what this does is when I change the selection in the drop box, I change the content of the HTML down here. So how do we do that? Like these drop-down boxes are select elements. I give it an ID. This is the drop-down. And then I give it a couple of options. These are the 3 options. Here we have option pear, apple, and plum. And notice that what computationally is the value is specified as an attribute, and that is independent of the text that appears here, right? And then you can specify which of those is the default selection. So if I rerun this, you can see that the default selection here is Apple because I put in selected here. And so then I add a div which has like a span in it. The span has an ID, fruit, and so here is where I want to insert the text based on the selection from the drop-down box. And so what I do here is I call document get element by ID fruit, and then set the element to document get element by ID drop-down dot value. So this is the initialization step. So what this does is the first time it executes without an event, this looks what is the actually selected value in this drop-down box and then sets it to the span in this div. This is what we get here. And then I retrieve the, I attach an onChange event listener to the drop-down box. So I say document get element by ID drop-down onChange, then I call the function. And here I'm actually using the event object to retrieve the target value. See how here I did this document get element by ID drop-down dot value. Here instead I'm using event dot target dot value. So this is like the event target that was clicked or that was interacted with or moused over. This is the DOM element that corresponds to that object. So that is a nice shortcut because here I don't have to do an explicit selection. I could do this the same way as I did it before. This is kind of like the same way as we did it up here, so this works equally well. It's just a little bit less elegant maybe. So works just fine. So instead here, what we do is whenever this is changed, we retrieve the element fruit and then set this to the target value of the dropdown. And notice that this is the value here, not the text. So these are the same because I put the same values in here, but this could be something else. Okay. And finally, we can of course listen to events that are triggered by an SVG. So here is a rectangle, and every time I click it, it changes color and increases its size. Again, everything just done in purely using the DOM API, no libraries. And this is also kind of like a lesson of how D3 does data binding behind the scenes. We'll talk more about this, but this is just like to illustrate this. So what I have here is I initialize with the rectangle that is just blue, and then I retrieve that element by get element by ID, my bar. This is this rectangle here. And then I set initialize this underscore underscore data underscore underscore. Like what I'm doing here is I'm actually attaching a new field to a DOM element. So the rectangle now has a variable that is called underscore underscore data underscore underscore. And of course this is arbitrary, right? I can name that however I like. I just used exactly the same naming that D3 does. So this underscore underscore is just a convention. It could be anything. But just to illustrate how D3 does it behind the scenes, this is how that happens. So I'm retrieving document get element by ID, initialize underscore underscore data as 0, and then on click on that my bar, I call a callback. I define a callback function that is called on click. Here I have a couple of colors that I use to iterate through. I'm retrieving the rectangle again from the event object, not explicitly. Well, I could also store the rectangle somewhere, but here again retrieving it from the event object. I am actually getting the current width, and then I am setting the current, increasing the current width by 10, and the colors. For the colors, I make use of this data object. So here I retrieve the data object's value, add a modulo 4 because I only have defined 4 colors, and retrieve this from the colors array here. So this is 0, 1, 2, 3. And then these are the colors that get assigned to this fill here. And then finally, I increase the value of the underscore data by 1. And this is how that rectangle here keeps growing and changing colors. Okay, any questions about that? So that's pretty easy, and we'll see in the second part of this lecture how D3 does that behind the scenes. Good, so you've already seen in homework 2 that you have to run a web server whenever you want to load data from a file for security reasons mostly. You can't like retrieve data, or you can't load a file when you just run an HTML directly in your browser. There's ways around that, but in practice you mostly want to run a web server. And so there's the simplest way is to use the Python simple HTTP server, which has the syntax for running that has changed between Python 2 and Python 3. But what I really wanted to show is the benefits of an IDE. So I've messaged on Slack that you can actually get a free license of WebStorm or PyCharm. Both are can do the same. PyCharm can also do Python, so if you do client-server development, PyCharm is better. If you just do web development, WebStorm is just fine. And what the benefit of those IDEs is that you can do things like syntax highlighting, which is of course most editors can do that, but they can do refactoring, they can also do interactive debugging, code completion, and then automatic code layout. And I just wanted to show quickly that you can also use them to run a web server. So you wouldn't have to use Python. So here I have, like, this is one of the event files, like this very simple event thing that we did. And if I were here in WebStorm, I could simply right-click on this HTML file and say debug that HTML file, and then that would start a web server out of WebStorm. And now you can see, like, I've also installed a plugin for Chrome, and I can interact with this just as I could before. But then I can also set breakpoints here. And so if I click on that, like, you actually see there's this, the execution is suspended. I can step over these elements, and you can see in line here, like, the values of all of these variables. So this is very neat for debugging. Whenever you have a bigger project running, I would definitely recommend that you use a debugger if you have any problems. Of course, you can also debug directly in Chrome. So if you go inspect here and then look at the sources, it's a little tiny right now. Then you can also put in a breakpoint here directly in Chrome, and then the execution is stopped here, and you can also see those values. But the nice thing if you do this in WebStorm is that you immediately can reload and you apply all the changes. If you make any changes here, they are of course not saved to your file. So yeah, WebStorm is free for everybody with an edu email address, so I would recommend that you get them. Of course, there's other IDEs that can do that just as well, but like, I personally like WebStorm. Okay. So that was kind of the summary of working with the DOM API, and now we will go into a little bit more advanced D3, like revisiting selections and data binding, then talking about scales and axes and the key functions for data. Okay. And this is the lecture -advanced -D3 lecture. Okay, so what do we have here? We have this very simple, like this, again a selection, but this shows just that I can select, as I mentioned earlier, I can select using this CSS style syntax by class name, by a hashtag, cancel button ID name here, or by element types. Again, note the difference between select and select all, but I can also use any other CSS selection expression, such as this parent-child combination. So here I'm selecting the spans that are direct descendants of the paragraph elements. So here you can see that in this HTML there is a paragraph that has a span that contains all the last word of the first, second, and fourth paragraph. and then I'm styling this using D3 so that we can see like these words actually match that selection. So here, this is what happens. D3 select all on this relationship selector, logging the selection here, and then I'm setting the color. And so what is interesting here, if you now like open up your console and looked at what is going on here, I'm logging the selection, and that is kind of like, here we can look at what that looks like under the hood. This selection is a data structure that contains a couple of different arrays. And the one that we have right now is this groups array. And this groups array corresponds to the update selection. And so you can see that all of the elements that match the selection here are in this groups array. So this is like 0, 1, 2. This corresponds to 0, 1, 2 here in that order. And so this is what this looks like behind the scenes. This is in the node list. We can then map data. So what do we have here? We have a simple example again where we start out with a couple of gray rectangles and then have our familiar blue and bigger rectangles. And so what we have here is we run select all on rectangles, and then I'm logging the selection. Then I'm doing the data binding, and then I'm logging the output of the data binding. And then we do some styling as we've done before, the width based on the data that we've seen here. So how does that look like? So now we have 3 different selections, and these are the ones that we're already familiar with: the enter, the exit, and the groups, which is also like we call the update selection. So the groups array contains the update selection. In this case, we don't have an enter and an exit because we had exactly 3 SVG rectangles, and we had exactly 3 data items, so we had a perfect match. So everything here is in the groups element. And then we can see those rectangles, and here we can see this underscore underscore data element. And this is exactly what we did earlier, but now what D3 did automatically by using the data binding. So here, this is where the data that is associated with that rectangle is stored. And you can actually, you can simply look at this by, I'm running this here, then I'm inspecting. You can see the console output, and then you can look at the selection here. You can go to the groups. I see 3 rectangles, then I'm opening up the rectangle, and at the very end there will be our data element. So here is the 127. And so this is also handy if you're not sure whether your data binding works properly, and if you have the right data item bound to the right SVG element, then you can simply log that element and look at what is the data that is actually stored in there. So similarly here I can retrieve the contents of the enter and the exit selection. Again, very helpful for debugging. And again, let me remind you of this diagram. Like here we have in the middle here we have, after we do a selection and then do a data binding on that selection, we have all the elements that could be successfully bound to the data and that already existed in our selection here in this update intersection. Then we have all of the elements that didn't have a match in the selection in the enter selection. And then we have all the elements that didn't have a match anymore in our selection in the exit selection. And we talked about how we can handle these explicitly last time, and I'll be revisiting it again. But this is really important, understanding that, and then you'll be fine. Okay, let's take a look at what we're doing here. So here I'm again creating this bar chart, but I'm creating it from scratch, and I create a couple of outputs in between. So here we log the data selection, we log the data, like what we get back from the data binding, and then we can see here this is the uninitialized, like this is the enter node before an append has happened. So this is kind of like, you remember that I talked about these uninitialized DOM elements before they're actually told what they are, before they're assigned to be a div or a rectangle or circle or whatever. And they're called enter nodes. And these enter nodes, they're short compared to other, to regular HTML elements, but you can see that they already have the data element in here. So the enter nodes they're not yet, they don't know what they're going to be when they're grown up, but they're still already bound to the data. Then later, after I run the append, we can also look at, like here I've done the append, I've used the enter, I've appended a rectangle, and then I'm showing the same thing again. Now I'm just rerunning a selection, and so we can look in comparison to that, we would see, like if we look at the output of this, so now like this is the enter selection, and you can see we have these we have the 3 arrays in here, like these undefined elements. That seems to have changed a little bit since I took those screenshots. And then here we have the initialized and existing rectangle elements, and they again have the data properly bound. You can see here. Okay. So when we update, this is an example that handles enter and update correctly. So we have like a run, and then I can switch to the next data set. And these two different data sets is the one has 3 elements in different sizes, and this one here has 6 elements in different sizes. And so what we do here is like the best way of doing it. We simply select all the bars. Note that I'm using these class.bars here, bind the data to it. This is now our selection. Then we are handling the remove. So we are removing all of the exit elements. Now I'm appending all the rectangles just with the minimal effort that I can use for appending new elements. So I'm saying append rectangle. I'm assigning it class, which is important because I'm selecting here not based on bars but based on a class, so I have to assign it a bars right away, and then I'm merging it with the update selection. And remember that means now we have all of the elements that are bound to data with the current data and the current selection. This is now all stored in this bars variable. And then we handle the updates and the enters, like the styling for both updates and enters at the same time. Again, using just very simple assignment of the data value to the width. And this, like I'm switching this, and this is actually how I can do events in Java in D3. So D3 select, I'm selecting the next element here. Remember this, like I did document.getElement by ID, .next, and then on click. And D3 does this a little bit differently. You select simply something, and then on is just like the syntax, and then you specify which type of event, and then you pass in the function that you want to execute. And the function that I want to execute is simply a call to the execute function. Okay, this is all you need to make this work the right way. Next we talked about transitions, and we can also do this with transitions, of course. So we have to kind of like, if we do transitions, we have to make a couple of decisions how we start, how we make things appear and disappear. Like here we start with transparent gray bars or with 0, and then this is kind of like the enter, and then we transform them into our styled example. So here is, we start out with this gray one, this is in the SVG, then I'm clicking on run, you can see that it transitions, like this one moves over and changes color, these ones appear at the right position and increase in size, and then if I switch to another data set, we can see that this is a smooth transition between them. So where were we? Here we handle the new elements by initializing them with width 0 and completely and in opaque, and I think in gray with the default styling. We remove for the exit selection, we fade them out, we transition them from completely opaque to transparent, and after that we remove it. Then here we do the merge, and this is now the update. And so here we just call update.transition duration, and then we apply the styling, the usual styling that we use. And so that's how we can do these kinds of transitions between two different data sets. So we already talked about grouping when we talked about SVG. Grouping is convenient because, like in this example here, I want to plot these bars, and then I want to plot a label next to these bars. And there's two different ways of doing this, right? I can identify the Y position of this, of these text labels independently of the bar positions, and simply handle those completely independently and position them accordingly. Or I could say each row here is a group, and once I'm in that group, I'm not worried about where exactly I position the rectangle or the text in Y. I only care about where they're positioned in X. And that is kind of like usually the better way, because in a practical example, you will have multiple things that you want to associate with a bar like this. You might have like something for picking that you're rendering and so on. So there might be multiple things that you want to associate with the bar, and so using a group is very sensible here. So what is the problem here? Like I'm running, again, switching between two different data sets. I'm creating this enter bar group. I'm appending a G element. I'm setting this to be of class bar group. I'm removing any extraneous elements. I'm merging the enter and the update selection into bar groups. I'm transforming now the group as a whole, like I'm positioning them in Y. So here is this translate 0 in X, and then I multiplied by bar height in Y. This is essentially what does the positioning in Y here. And now, after I've done that, I go back to the enter bar groups, append the rectangle, set the rectangle to the right width, then I go back to the enter bar groups, append the text, move this over by the width D, which we used here to draw the bar, add a little bit of padding to it, don't move it over don't move it in Y, and then I'm setting the text to be D. So this essentially shows us the label. This here defines what the text is. And then I'm essentially here for dy, I'm simply using bar height divided by 2, just so that they're properly centered. And so this is it, but the problem here now is that this doesn't actually work for switching between two different data sets. So what did I do wrong? So there's like a couple of things that are not as obvious, not quite so obvious here. I essentially only use these enter bar groups and appended the rectangles. I'm not explicitly updating the rectangles here. So I have to take quite a different approach actually to implement this. And the problem that happens here is that the update is actually correctly applied. Like the updated data in here is actually correctly applied to the group, to the enter bar group or to the bar group the SVG group, but it is not passed down to the rectangle in the text. So the group that contains the rectangle in the text is correctly associated with the data, but the rectangle and the text were not even notified of the update. And so if I look at the console output here, I can see that the group, the G element here, is associated with the right data value with 100, but its children, the rectangle here, is still using the old data, the 61, and that's why that doesn't work. And so how can I fix that? I can fix that by separating out again the update and the enter selection, and by explicitly retrieving the rectangles and the text elements in the group using a select. So what does that mean? Here I'm again just appending the new elements. I'm exiting. Here I'm appending immediately a rectangle, but I'm actually not doing any of the initialization. I'm just setting it to some default values. Then now I append the text, and that is not initialized at all. Now I'm doing the merge, and I'm translating them to be at the right Y position. And now is the tricky part, or the part that is important to know about, because it's kind of not super intuitive. Now if I call bargroups.select rectangles, like by actually selecting what is in these bar groups, by calling the select function, the data is updated in all of the children. And so after this happens, my bar groups, the bar groups, the nested elements of the bar groups do actually get updated the data. So here I'm calling bargroup.select rectangles, and then now I have all of the rectangles here in a selection. I'm transitioning them in with a certain width and an opacity. And I do the same thing for the text. So I'm calling bargroups.select text. So I'm retrieving all of the text elements in the bar groups, and then I'm styling those accordingly. And then I do a couple of tricks that the transitions look nice. And so what I get now is these fade in, and then once they're faded in, the text labels appear. And then if I click on next data set, the text labels disappear, and once they're moved over, they reappear. So is that clear what I did here, and why this works and why it didn't work before? That's something that is like, if you ever encounter that, it is really hard to spot. But if you know that if you have a nested selection that you need to call select on the sub-elements to pass the data down, then you have solved the problem. And that's something that I personally also encountered when I started out with D3. Okay. So in your homework already, you had to do some manual transitioning between. We had these levels and positions, and those were not exactly screen coordinates, right? So you had to multiply this with a constant factor to position them at the right place. And this is not uncommon. Like, very rarely will you have a data set that like maps one-to-one to perfect screen coordinates. So here is a data set that doesn't really work well with screen coordinates. I have 0.3, 0.01, and 1.5. Just doing our simple example again. And as you can see, these are very, very tiny bars. So not particularly useful. I cannot make any comparisons. And so what can we do about this? We can multiply this with a constant factor. But more generally speaking, we're looking for a function that maps an input data set D to a derived data set D primed. And that can be anything. That could be like a simple multiplication, it could be a division, it could be a log transformation, it could be a binning. So there's many, many different functions that are sensible in different situations. So we can write a function like this ourselves. And this is maybe something that you've done. Maybe you've just like multiplied it statically, or maybe you've used the scale function in your homework, just like I do here, where I say scale function input is input multiplied by 500. And so that, like now it's the same data set. If I multiply that by 500, that works just fine, and I have now a bar chart again. And if I change this multiplier here, I can see that I have a smaller bar chart. So this kind of solves the problem, right? But it doesn't solve the problem in a very, let's say, sophisticated way, and it solves the problem for like a linear transformation. But there is actually something that D3 can do for us that handles all of these different cases, like logarithmic scales, power scales, discrete scales, color scales, ordinal scales for ordinal data, scales for temporal data, and then also plays nicely with legend and axis. So how can we do that? D3 provides these scale functions. And so this is also something that has changed since D3 version 4. D3 version 3, it was d3.scale.linear or d3.scale.log. Now they have flattened the namespace to be in line with ECMAScript 6 coding standards, and it's d3.scale.linear or d3.scale.log. And so this is how I create a scale. d3.scale linear, and what I need to define here is what's called the domain and the range. And the domain is this input space of the data. So like we have our d prime, but that's not necessarily exactly what we have in the data. We might want to be a little bit smarter about that. And so here I'm defining the domain to be from in the space in the interval from 0 to the maximum value of the data array. So the data array here is between 0.01 and 1.5. Why am I using a 0 here and not d3.min data?
Because you might want the 0 value to be shown in your...
Exactly.
Yeah.
So we very often want to show a scale that starts at 0, right? This is just a good visualization design. There's of course exceptions, and I'll actually be talking about that in the next lecture on Thursday. But in practice, we vary like a bar chart. We usually want to start at 0, and we want to go at least to the maximum data value. So this is our input data set, and then here we are telling D3 what do we want to map it to. This is the range, and for the range I'm defining here 0 to 700, and that is exactly what I use for like plotting the width of the pixels. So now the biggest value in my data set maps to 700. 0 maps to 0. And so this is exactly what I want. And if I do that, I simply get this from 0 to 700. If I change this here to 400, I get a scale from 0 to 400. How do I use that scale? Well, it's just a function. It works just the way as our handwritten function does. We simply call x scale of d. One important note, which we'll see later, that these scales, when your data changes, you also have to update your scales. So if your domain changes, you have to update, reinitialize your scale to show that properly. If that doesn't change, you don't have to do that, of course. Okay, so this is still pretty simple. Now we can actually use a log scale here. I'm removing this. Oops. And then I'm calling scale log, and since the logarithm of 0 is undefined, I can't start at 0, but I'm starting at 0.001. And now if I run that, I get a log transformed bar. So you can see that this bar here appears much wider than it did before. And so I can quickly switch out the function that I care about here using these different D3 scales. Okay. Sometimes you have data values that are larger than your domain. That sometimes makes sense. And if you have that, one thing that you can do is clamping. So let's imagine like this rectangle here is the screen that or the space that I have assigned for my chart. And then I have one outlier, one massive outlier, and everything else is kind of small, and I still want to see the variation in the small data set. And so if I just plot this and say, okay, I want my domain to not be kind of screwed up by the largest outlier here. If I don't account for that specifically, and I simply set my domain from 0 to 1.5, but I have a value with 2 here, then D3 simply plots above or like beyond the space that you have kind of allotted it, right? So if you have a scale function and you have defined a domain and you pass in something that is larger than the domain, of course what you get is something that exceeds the range. And that is something that is sometimes sensible, but sometimes it's not sensible. So most of the time you want to update your domain properly. But sometimes it can make sense to not update the domain, and then you can run the clamping. And so if I do clamp the data set, we can see because there's a semicolon. We can see that now any value that is bigger than our domain is clamped to the maximum of the domain. And so this is not good data visualization. What you would do here is you would also check whether this exceeds the domain, and then you would draw a symbol here and indicate that this is a broken scale, for example. But just if you need to, you can use these clamp functions. I already mentioned that you can also do color scales. So here's a little bit of a bigger data set. We have a data set that has positive and negative values, and we want to have a bar chart that renders in positive and negative charts. This kind of reminds me of the bikini chart that we had about Bush versus Obama job losses and gains. And so what we're doing here is a redundant encoding by width of these bars. Like here we have the 0 value. Everything to the right is bigger than 0. Everything to the left is smaller than 0. And then we are also encoding redundantly with color. So it's like at the center, you can see this here. This is almost completely gray. These are like slightly red. This is very red. And the same for the blue. The longer, the darker the blue. And so we're using a redundant encoding for color and width for these bar charts here. And so how do we do that? This is actually very nice. What I do here is I say d3.scale linear for a linear scale. I say from the minimum of the data to the maximum of the data. In this case, because like we have a 0 value in the middle, I'm using 3 interpolation points for my domain. So from minimum to 0 to maximum. And then I'm using 3 kind of like the color interpolation. This is from dark red for minimum to light gray at 0 to steel blue at maximum. I have the scale that I use for the width is just from D3 min data to D3 max data from 0 to 800. And now I'm rendering those rectangles by there's some kind of I have to take care of where I start a bar. I'm using the minimum of 0 or D, and I also have to take care of what the width is. The width here is the absolute difference of D, of the scale value of D and the scale value of 0. And then the interesting part here is actually just the call to the color scale. And I'm calling the color scale with the numerical data value that is then converted to a color that I then here apply to the fill. And so this is all that I need to do. There's nothing more complicated about interpolating those colors between the 3 different points. And I can of course use this with categorical values as well. I'll have an example later of how we can use those scales, color labels and so on with categorical values. Okay, so up to this point we have only talked about kind of like very abstract representations on the screen where we had bars, but we never had a specific idea of what the data behind those bars is, with the exception of when we rendered the labels next to the bars. What we in practice very often want to do is we want to have axes for the charts. Drawing axes can be pretty tedious because you have to worry about how do you place your ticks, how do you arrange those axes and so on. But fortunately, this is something where D3 is also very helpful. D3 has extensive support for axes. So here's an example for an axis based on our previous chart. What we get here is, if I run that, I get a chart like this with an axis here at the top. So how do I do that? First, I use the same data here, and the thing is that the axes work really nicely together with the scales. So here I'm using the same x scale from minimum to maximum and the range, and then here I'm defining the x-axis to be an axis bottom, and this is where there's a couple of different axis functions depending on where I want to place my axis, on the bottom, at the top, on the left, or on the right. There's different functions, and they're different in terms of how they are styled, but otherwise they're of course the same. And then here, this is where I assign the scale to the axis. So now those two are tightly synchronized. And so for example, if I we know the D3 now knows it wants to render a scale from minus 1.21 to plus 1.2. And so this is the scale that we get here. minus 1.21 to 1.2 something. That's the scale we have here. And so when I change that scale, when I do a data update, for example, and I've done it like this, then the axis will also automatically update. Here's just the rendering, and then I'm appending the axis, like I call like the SVG element, append a G to the SVG element, and then I call this x-axis. So what this tells us, this x-axis is actually a function in that case. And so now if we look at the output of this, we can see that we have our SVG here with all of those rectangles. And then here at the bottom, we have a group element that corresponds to the axis, and then D3 has taken care of all the like rendering the ticks, the labels, and so on, and positioning them nicely. So we see this is like the callback here created this axis for us. So obviously this axis isn't perfect, right? This is not a, like, this here doesn't look great. There's 1.21, and then the spacing here isn't nice. Here I'm actually rendering beyond the screen. So this is not ideal. We can actually improve this a little bit. We can style the axis, so we can we can assign a class to the axis, and then, for example, here I'm making the lines appear green. I'm making the text appear serif and in font size 14. What I also do here is I kind of take care a little bit of like padding and heights, so that we kind of get into like real chart design where we have to worry about those details. So I have a height, a width, and then I have a padding on all sides. I'm setting the SVG attributes here, that the real width of the SVG to be width plus 2 times my padding and height plus 2 times my padding. Now I'm appending a rectangle just to show what the this is this gray rectangle that shows essentially the rendering area that we've designated, not only the SVG as we had before. And then I run a very similar function. The one thing that I also do here is I call the scale to be nice. And if I call nice, then D3 has a pretty sophisticated algorithm to find like a balanced scale. So for example, if you have an input domain from minus 1.1 to plus 0.9, it will create a domain that is in fact from minus 1.2 to plus 1.2. So it will do those roundings. It will make sure that if your data is roughly balanced, that your scales will be roughly balanced. So you can simply trust nice, look at how it works, but quite often it works quite well. Here I'm again defining the axis. I'm setting the scale. I can actually also define the ticks. I'll show you later. Here I'm taking care of the padding that I introduced. So I'm using like one big transform here, and yeah, this is basically it. And then here at the bottom, I'm also moving this the axis. I'm calling the axis. I'm setting it to, like, I'm calling the axis here. I'm setting it classed so that the styling that I applied at the top is actually applied to the axis, and then I'm also moving this to the bottom of the chart. And so how does that look? So if I run that now, we can see I have this nice chart which has a very nicely rounded axis from minus 1.4 to plus 1.4. Everything fits on the screen. These are equally spaced, and this is at exactly the right position. So this is a nice bar chart where we like this. This is actually like usable. Okay. And so in the last couple of minutes, I want to walk you through one little bit more complicated example with a complicated data structure. And so what I want to show you here is how can we access data from object, which is something that you've already done in your homework, how to sort data, how to properly deal with padding in an SVG, if you like as before, but a little bit more sophisticated, how to use a scale with bands to evenly space the bars. So up to now we've always used just some multiplier. I multiplied something to position the bars, but it's actually better to use a D3 band scale for that. How to update the scale, how to ensure object consistency for transitions with the key functions of the data mapping. That's kind of the main lesson here. And how to use object notation to define many attributes at the same time. Okay, so what do we want to do? We have this long example here. I'm going to look at this in the new page. I have this data set that I made up of some store or some seller sells some groceries, apples, bananas, plum, bread, cereals, beer, and wine. These are different categories. There is fruit, there is dry goods like bread and cereals, and then there's alcohol, beer and wine. Categorical, these categories are color-coded with violet, green, and orange. And then here we have like sales volume in whatever tons. And we see that we sell a lot of wine in the store and a lot of beer, more fruit though, and not a lot of cereals and beer. And then I want to sort this chart. Right now it is sorted alphabetically by the name of or it's actually sorted by product groups. So first come the fruit, then come the dry goods, and then comes the alcohol. And now I'm sorting it by product name. And now I'm sorting it by the tonnage, by the quantity of sales. And so this is the chart that we want to create here. And you see these transitions. So what do we have to do to make that happen? There's a couple of things. So we start out, here's the inline data definition. We have very similar to your homework where you had this phylogenetic tree where you had an array of objects. And the objects here have these three parameters: product, tons, and type. And we have this for all of these different products. Then I kind of took a shortcut here. I'm defining the types manually because I need them for a scale. Then I am retrieving the maximum width, the biggest element, also for scales. Here I'm defining the margin and define the width of my SVG. Again, we do this is the styling. Here I'm setting the width of the SVG to be the width of our chart plus the margin on both sides, the same for the height. Now I'm appending a master G element and move everything by those margins. And now I'm again at a coordinate system that starts at 0. I don't have to worry about these margins anymore. Here is the implementation of the dropdown. I'm using the D3 notation for the events on change on this dropdown element. I am running a function that does the sorting. And so this is whenever I change something here, this event here is called, and that resorts the data based on what we have selected in this dropdown element. So what does that do? We're retrieving the active element again, so this is the dropdown box. And now I am calling the sort function here, and I'm passing in this custom implementation for the sort function. And the sort function here, there's two different cases. If I have product or type, I do a lexicographic sorting of the product. So I've used this -1, B is bigger than A, 0, B and A is equal, and plus and positive values, A is bigger than B. This is kind of what I'm doing here for lexicographic sorting for the product names and the types. And then for the tonnage, for the sales volume, I'm simply doing the same thing by doing a subtraction. So this function gives us, what this does is it takes the data that we've defined here, this array, and sorts it either alphabetically by product, alphabetically by type, or numerically by tons. And so we are actually changing the data array here whenever that is changed. And then whenever this function is called, or when the dropdown is called, then I'm also calling the execute function to do the actual update. So this is then something we haven't seen yet. This is the ordinal scale with the scale band, position, the bar and size the bars in Y direction. So this is very, very neat if you work with a bar chart. So like here, if you have like bar charts and you have like 3 items, as in this case, you can use these scale bands and say, this is my range, I want to put this many bars in it, and it will automatically provide, like do all of the spacing and the calculation for you. So you can then retrieve the values for the width, the step width, the bandwidth, the padding, and the range, and so on directly from the selection. And so you have things like here, the step width is between those bars, the bandwidth is the width of the bars, the padding outer, padding inner, and so on. And so you can retrieve all of those values when you do the drawing. And so this is very convenient because you don't have to, this takes care of a changing number of elements and dynamically rescaling the width of your bars if you need to. And so here, I initialized this from 0 to height with a padding of 0.1. This is kind of standard. I'm just assigning an axis at the bottom. I'm appending this axis to a group element. I'm calling it. And so here, this is the execute function where essentially most of the stuff happens. This is either called when I click the run for the first time. If I reload this, if I click run, execute is called. But also whenever I change between any of those types based on this callback on the change event on the drop-down, this is also called. So here we handle the update. Here for the Y scale, this is the scale for that we used here with the scale bands. I'm setting now the domain. Note that I didn't initialize the domain here. I only initialized the range. I told it goes from 0 to height with a padding. And now here I'm setting the domain. And my domain here is a categorical value, which is essentially an array of the products. And so I'm passing in this anonymous function with the arrow notation that returns the data.map on this d.product returns an array with the product name. So this is now my domain, my scale for these bars. Now I'm actually mapping, like here, I'm selecting the bar groups. So these are the actual bars that we see here. Like each of these here, including the label, is a bar group. And this is the key part here. Up to now, we've always said dot data, brackets, and then pass in the data array. Here I'm specifying a second parameter. And the second parameter tells D3 for a more complex object, what is it that you use to compare equality. And so here I'm telling D3, I have this more complex object that is a product, and what you should use to compare equality is not the sales volume, is not the product category, but it's the product name. So I'm telling it for this object, use this field to identify equal objects. So for example, if I had different years with these sales volumes, if I use that notation, I could still identify that easily between those different states. And that is very important. This is also why you can have both an enter and an exit selection at the same time. Because some values can fall out, some values can come in, some values can stay around. And so here we are giving up this simplistic association from some SVG element to some data element, but we're explicitly telling D3 what are the equal things that you have to look for. So this is the most important part here in this example. So the rest is here rather straightforward. We append the group element, position this group element globally for both the label and the bar. Here we are rendering the text element. There's like a couple of minor things that we do here. We do a text alignment baseline middle and then position it in Y by Y scale.step half. This is kind of like, there's actually two things here. that I should note. The Y scale, the band scale that we used here, is what we retrieved here. So by calling Y scale on d.product, we retrieve the position of that particular product. Remember that we initialized the Y scale with the product names up here. No. Here we defined it, and here we initialized it with the domain with the product names. And so here we are making use of that and positioning the whole group based on that. And here we are. Here we retrieve the step size, dividing it by 2 so that we have the middle of those bars, and then we use alignment, baseline, middle to render the text in the middle of those bars. And so now the middle of the bar is perfectly aligned with the middle of the text. And so that is pretty neat. There's some other details on how to anchor stuff. That's not that important. Then we are taking care of transitions in the enter. Here I'm now appending the rectangle. Here the Y position is already taken care of, but the height here I'm accessing the bandwidth again to properly define the height of these bars. I'm using a color scale for the fill. This color scale, I missed that. So the color scale uses a scale ordinal, which we also haven't talked about yet. The scale ordinal gives, what I put in here are these 3 different types: alcohol, dry goods, and fruit. And we say this color scale. I've imported this color scale. This is one of the Color Brewer color scales, and I've done a global import from Color Brewer up here. And so this color scale is defined because of this Color Brewer import here. And so I'm selecting one of the Color Brewer scales that has a size of 4. I don't actually need all of them because I only need 3, but as long as I have enough, that is fine. And that is basically it. The only other thing is that after the sort, I have to do this transformation. So I'm doing the transition here with a duration of 3 seconds that does this transformation. And so again, between these different update events, the scale is changing. The important part here, why the sorting works, is because I am actually redoing this assignment of the Y scale to the product list again. So what I do is whenever I hit the drop-down box, this is resorted, and then this sorting is used from scratch to initialize the Y scale here. And that's why these bars are positioned at different places, and that's why they move nicely between those different positions. So I take it this is probably a lot of stuff. This is a long example, but this is kind of also designed for you to go back and take out examples when you need to do something like this for you in the homework. And I hope with the annotations and so on, this is kind of you can understand what is going on. And if not, I'm happy to take any questions. On Thursday, we'll be talking about design guidelines. It will be a little less dry. There's a lot of interesting examples of how people screw up on visualization designs. And then next Tuesday, Carolina will be talking about maps, both maps in D3 and how we can render with D3 on top of Google Maps. A week after that, we'll be talking about layouts, how can I render tree maps, pie charts, or force-directed layouts, and so on. And that will then conclude the technical parts of the lecture in 2 weeks. Okay, thanks everyone.